So the recursive formula is great. You can continue multiplying on to get to future term numbers. But what if I want term number 100? Just like with arithmetic, we need to have another formula, one that we can just plug in the term number we want and it'll spit out the value of that term. So for this, we need an explicit formula. This is your formula. I showed you in the previous video where to find that on your formula sheet. There are two things you're going to have to plug in here. You're going to have to plug in your first term, same as we did with arithmetic, and you're going to have to plug in your common ratio. I showed you in the previous video how to find that common ratio, or in the first video how to find that common ratio. So let's do a couple of examples. This tells us that the first term of a sequence is 128, so a sub 1 is 128, and the common ratio is 0.5, so r is 0.5. It wants the 10th term of the sequence. So first, let's plug the information we have into our formula. So a sub n equals a sub 1 is 128 times 0.5 raised to the n minus 1. If I want to find the 10th term, then all I'm going to do is I'm going to say a sub 10 is 128 times 0.5 raised to the 10 minus 1. Now something to be careful of here. You can do this by hand, but you've got to make sure you follow your order of operations. I've got parentheses, then exponents, then multiplication, division, then addition and subtraction. I need to do this 10 minus 1 first, then go ahead and do my exponents, then multiply. So here's what it's going to look like. A sub 10 equals 128 times 0.5 raised to the 10 minus 1 is 9. I need to be able to do my exponents first, which means I've got to go ahead and take care of that subtraction before I take care of the exponents. So then 1/2 to the 9th power, I'm going to put that in the calculator, and I get a crazy fraction, or crazy decimal. I would like to have that as a fraction, so I'm going to convert it and put 1 over 512. Most of the time you're going to want to stick with fractions, otherwise you're going to have to estimate, and that's never fun. So I have 128 times 1 over 512, and when I multiply that, I get a nice, pretty 1/4. So a sub 10, the 10th term in this sequence, would be 1/4. Your other option is you could have put this whole thing into the calculator all at once, so it would have looked like this. 128 times 0.5 raised to the 10 minus 1. It should look like this when you put it in, and when you hit enter, it immediately gives you this 0.25, which is the decimal equivalency of 1/4. If I convert that, then I get the 1/4, which is the same answer I got before. So it's up to you which you'd like to do on that. Let's go ahead and do another example. This time it didn't straight up tell us what the first term is. Instead, it gave us a sequence. But I can look at that term and I can see that the first term for this is 8. I also need to know my common ratio. Well, when I look here, to get from 8 to negative 16, I am multiplying by negative 2. The fact that it's switching back and forth from positive to negative to positive to negative means that I am multiplying by a negative, because if you think about it, negative 16 times negative 2 would be positive 32. Positive 32 times negative 2 would be negative 64. So my common ratio here is negative 2. All right, so a sub n equals, my first term is 8. My common ratio is negative 2. You're going to want to put that in parentheses to keep that negative safe and keep it separate from the multiplication. And then raised to the n minus 1. There's my explicit function, or my explicit definition. Now if I want the 13th term, then I'm going to go a sub 13 equals 8 times negative 2 raised to the 13 minus 1. I'm going to go ahead and put this in the calculator. So I'm putting 8 times negative 2. I went ahead and put that negative 2 in parentheses because I just think it's safer. It keeps my negative where it needs to be with that base of negative 2. And then I'm going to raise that to the 13 minus 1 power. So it should look like this when you've put it in. And when I hit enter, then I get quite a large number, 32,768. Like I said before, do not be worried when these numbers get really, really big, really, really quickly. It's to be expected because you're multiplying by 2 over and over and over again. So the 13th term then is 32,768. It was positive. I can feel safe in that because I know I put my negative in the right spot in the calculator. And now you guys are ready to go ahead and do a couple of you tries. We did one like each of the ones that I did, and I will see you back in just a second for video 4. Bye-bye.